This is the end result of what we're going to produce going from Carlson PtCloud using a scan of a poured floor to produce a cut fill map with volumes and legend. You can see the base elevation I chose for this pour was 934. It showed me what was above 934 and what was below 934. To start from scratch, I'm going to type E here, WP for window polygon, and delete my cut fill difference map, legend, and my output text reports. Okay, let's get started. So we're going to load up PtCloud, load up the PtCloud Manager. We're going to do a new job, and I'll just call this scan space 03, and we're going to import a scan stored as a LiDAR file, scan 03, and it's already converted and registered. So we bring it in. Let's just see how big this file is. It's about 12 million points. Let's go take a look at it. Create a scene, and there it is. And right now the area of interest will be right here. We want to make a grid file of this area there. So what I'm going to do is go to Action, go to Perimeter, and I'm just going to go straight down here out to here and grab that area. Let's do invert, hide, and now that's the area that I'm going to be looking at, and that is right there. We're going to make a grid file of this site right there, and to do that, here, let's go up to the scene here and bring them up to 5. So there, we made the points a little thicker. So I'm going to make a grid of these 3 tiles right here, 2 columns of 3 rows there. So I'm going to go up to Action, go to Perimeter. I am now going to pick those, what I call tiles, hit the right key. That creates the perimeter, and then I come down and do cloud, and we're going to call this floor 03. And now let's do none, go back to project, and let's close this and load up and make a scene of this smaller cloud. So I could double pick on it or just hit the right key and then pick view. Pick OK to go with the default scene name, and there is the cloud again. Now I just want to take a look at it, and you can see that if I scroll over my mouse up here, notice 934, just the elevation will display here, is about the highest point. Everything else is pretty much below 934 except for up here. So 934 is right about here, and it cuts across right around there, 934. Alright, so we're going to want to know what is above and below the flat plane of 934. Now, when you look at your site, because I have one scan, I won't have much sponginess, I call it, or thickness. When you have multiple scans registered, sometimes you can get a little more sponginess, where points that might be a couple eighths of an inch below or 16th of an inch below another surface just because of the way it was registered. So I'm only brought in one scan for these 6 tiles here for the concrete floor. Now, when the reason why I am viewing this, I want to go to the vertical exaggeration down here and go to 10 to 1. Certainly looks flat now, doesn't it? Now, when I go to 10 to 1, I don't know if you can, well, you certainly can see it there. It looks like it actually undulates at 10 to 1, so you can clearly see that at a vertical exaggeration of 10 to 1 vertically to horizontal, that this sloping surface that looked flat is actually has little undulations in it. Alright, we're going to go back to vertical exaggeration of 1 to 1, and set it back to plan view. Okay, let's make a grid file. The grid file is the method that I recommend if you want to create a difference contour map back in Carlson Civil in CAD, and you do that from the PtCloud grid file. So I'm going to pick grid, and another thing I want to point out is these little seams in between the panels are very low, and I want to ignore them. Here, if I window up, you can see that obviously these are low, and I'm more interested in just going from surface to surface there from the high points, and ignore the low seams, which would maybe force a trend of it going down. So just something to be aware of how I create this grid. I'm going to do it from all the highest points, not the lowest points. I sometimes pick the lowest points if I'm working outside and I have grass. I want to pick the lowest of the lowest points on top of the grass, so I don't pick on top of the grass, or in the middle of the grass I pick as low on the grass as I can be. But in this case, I'm going to make a grid file from only the highest points. So I pick this, and it says use current scene bounds. That's this yellow bounding box. If you don't have that, you go back to the project box, pick settings, and make sure from viewer settings here that this bounding box is turned on. You can see it shows up here. If I turn it off and pick the green check, it disappears. If I go back to settings, pick viewer box, and check this box, toggle it on, come back and pick the green check, the bounding box appears. So that is the bounding box that when I pick action and go to grid here, that use current scene bounds. That's what it's saying. Use the yellow bounding box. If not, I can pick it on the screen or pick it from an existing grid file if you're doing grid to grid to surface grid volumes. In this case, we're going to just do use current scene bounds. Now, if you have coordinates here, you know that it's picking up the coordinates of the yellow bounding box. There's the cell size. It's telling you that dimension of cell is 0.25 by 25. So we're going to create a new file, and we're going to call it floor 03, and you can set them down to 0.1 to 0.1. The smaller you make it, you may get a tad bit better volume or reporting, but quite frankly, doing every 3 inches is probably overkill. If I make them too small, it might actually pick up the valleys between these seams here, or panels on the seams. So 0.25, 3 inches should cross over these and just use the local maximum. And that is the key one right there. You are picking the highest elevations, not the lowest elevations, or the cell average. So I'm going to pick the local maximums, and that is the cell size, dimension of cell, right there, and number of cells. If I pick that, well, it's not updating here, but dimension of cell is set here, 0.25, 0.25, and if I pick OK, creates it and will draw it. And as soon as you see these little red X's there, you can see that it is drawn these little 0.25 using the highest points on the grid. If you see any anomalies on the grid, then you know there's something wrong, but that doesn't, it looks just fine to me. Okay, let's go back to plan view, close this view, go back to the project, save the project, and now if I go to processed data, you'll see that I have a new grid called Floor 3. To use this in Carlson Civil back in CAD, you have to export it. So I'm going to do export, and I'm going to call it the same name, Floor 03, and this creates a Carlson grid file. And there we go. Save it again, and I'm going to exit, and now I can plot that, but I'm not really interested in plotting the grid file. I just want to get right to the volumes. So I go to the surface drop down, and we're going to select volumes from grid surface, one grid surface volumes. So I pick this, and it says select down here in the command prompt. It says select the inclusion perimeter. There is none, so I hit enter for none. Select the exclusion perimeters, polylines, and there are none. I hit enter. And now it says specify the grids file, and that's going to be Floor 03. Pick open, and it says extrapolate grid to full grid size. No. Reference elevation is 934. And now volume report options. If you want to see or create a grid file that you can do spot elevations anywhere on it to see what the differences are, you can create a grid file, and it's actually just a grid file of the elevation differences from 934 anywhere on that grid file. So I'll go ahead and make that for other use. Draw depth difference contours. I'm going to do every tenth. I've already done the site once, and I know that there's like 4/10 difference. So I'll do every tenth. Draw depth difference in each cell. Now it gives you an option to skip cells. Obviously, if I don't want to do a cut fill every 3 inches or 0.25 of a foot. And I'm going to skip volume in each cell. And where it says draw cut fill color map, I'm going to check that box. So it makes the nice blue for fill, red for cut, and white for the default 0, no cut or fill, or little cut or fill. And then calculate elevation zone volumes. I'll have that checked too. So at this point, I pick OK. This is the report, and it says that the reference elevation is 934 from this floor03.grd, and total inclusion area 850 square feet, cut to fill ratio 0.21, average cut depth is 0.7, and average fill depth is 0.15, about double the cut. Maximum cut is almost 2/10, and the fill depth max is 0.36. The cut volume is 0.71 of a cubic yard, and about 10 times the amount for fill, which is 3.3, or 5 times the amount of fill, which is 3.3 cubic yards. We're going to plot that to the screen, so I pick this. 1 foot will be the height of the text. This is the layer and the standard style, M text, and right now I'll just pick out a little bit here. I'll pick right there, hit return for due east. We'll close the door to exit, or pick the closed door. Now it wants to write this file, and I'm going to type in floor 03 DIFF. And now it comes up and says, you can see the maximum cut is 0.189, maximum fill is 0.359. So if you go to set interval and set it to 0.1, which I've already done, you can see that the maximum cut will go from these 2 values here, and the maximum fill will go to these 3 values here, which is 0.359. So we pick OK. The coloring will be red, white, and blue. The max cut will be the darkest red. The max fill will be the darkest blue. And the 0, or no cut or fill, or limited cut or fill, will be whitish. I pick OK. And there you go. So we have a little cut in red up here. This is where the daylight or 0 is, and this is where the excessive fill or the largest amount of fill would be down at the bottom here. Pick color legend. I'm going to pick right to the right. Size, I always default to 10. I type in 1 for small areas. And it says label, and I'm just going to do summary. Now, it comes up and says elevation difference options for plotting the cut and or fill. Now, we certainly don't want to see text every 3 inches, so I'm going to type in 0.25, that's very small text, and we're skipping every 8 rows and every 8 columns, so that, here I'll make it even smaller, 0.2, and just pick OK, so it should be every 2 feet. And there you have it, the text is plotting every 2 feet, and the size of the text, though it's small, is plotted on top, or brought the cut fill color map is shown below, and the cut fill text is shown above the cut fill color map. So the highest point is, or the highest cut is 0.18, and going down here, apparently the highest fill is 0.34. So that gives you a breakdown of it. And now okay, now if I calculate another plane. Oh, wasn't done yet. I see. Hit no. And here I'm going to do CTRD, capital D for diff. 0.1. I'm not going to label the contours. I don't like the way it labels, so I'm not going to label it. I'm just going to 0.1, reduce vertices. It was 0.01. I typed in 0.1 and pick OK. And there are the labels, and you can see that's the daylight line, or the 0, and with the smoothing or reduced contour vertices, it made a fairly nice little contour map, a difference contour map. So I label it after the fact. I just come up here and I'll do contour labels, locate local elevation label, and it says decimals for label, one decimal place, and near on, and I'll just come up here. There's no label here. I'll just pick here. Second alignment point is here, and now I'll just pick right there and right there to break it. Here's the next one. I'll pick here and breakpoint. There's a 0 there. You just can't see it. And then right here, oh, I broke out of the command. Let's do it again. Near on and label. I'll do it that way, and we'll break it there. And I'll come down here and pick this, pick that, and second label point will be there. And I'm going to break it here and here and move it. And then we'll come down here and pick here. Pick here, and we'll break it right there. Okay, and now I'm going to hit return. I've labeled those 3, and I'll move that there. And then I'm going to just type in change, the AutoCAD or Untitled change command. Pick that one, and that one. Hit return, P for, and now I'll do change again. I'll do P for properties, C for color, and that is 0. And then the last one, I'll change it to I want 1 for red. And if that was in the darkest of the dark red, it might not be easily seen, but it's still whitish red there, so it's very easy to see that. So there is the fill contours. I guess I could have made them blue if I wanted to. The last thing I do here is I double pick here and come down here and do base elevation 934.00 foot mark, and hit return, and then I type in change, hit return to get out of the edit command, and I pick this guy here, enter, type in P for property color, and I make it green. So we know that this is 0 here is the base elevation of 934, and there you go. That is the volume report from a base plane of 934 coming from a grid file and plotting it inside of CAD.